Okay, here we go. Chapter 3, exam review. So this is with logarithms and exponentials. And the first section here in the worksheet is to work with exponents and the exponent properties. Order of operations is still the most important part here. So if we look at this first one, negative 5 squared, it would be different if it were negative 2 with negative 5 squared. With number 1, we are just squaring the 5 and there's a negative out front. This is the same thing as negative 1 times 5 squared. So this gives us negative 25. But if we put the negative 5 in parentheses, that means we're squaring the whole thing, including the negative 5, or including the negative, so we get a positive 25. Number 3, we have a negative 4 exponent. So we distribute this in, basically multiply all the exponents. So this is really a 2 to the first power. So it becomes 2 to the negative 4th, x to the 12th, but we can't leave any negative exponents. So this 2 to the negative 4th becomes 1 over 2 to the positive 4th, which is 16. So we get x to the 12th over 16. I should box my answers here so I know that that's the answer. Okay. Next up, we have a multi-step problem. So what we first want to do is distribute in the exponent. So again, we have this negative 4 squared. So that is going to be a negative 16. And then we have the x to the third, which is going to be x to the 6th times 3x to the negative 2nd. Don't worry about making this a fraction or putting this in the denominator right now because we can just add the exponents. And actually, now that I'm thinking about it, this right here, this negative 4, that's actually going to become a positive. Because, again, this is the same thing as negative 4, the whole thing squared, or negative 1 squared times 4 squared, which is positive 16. Sorry about that, but we have 16 times 3, which is 48. X to the 6th times x to the negative 2nd, we add the exponents, so we get x to the 4th. Let's make that x look a little bit better. And that is our answer. Next up with this, we have a sign here. So we're going to have to distribute. So, just like this. So we're going to have 2x to the negative 3rd times x to the 5th. That's going to bring us to 2x squared. Again, we add the exponents. Minus 2x to the negative 3rd times 2x to the 3rd. Well, the 2 times the negative 2 is going to be 4. And the x to the negative 3rd times x to the 3rd, we add the exponents to get x to the 0 power, which is not 0, it's 1. So we get 4 times 1, so that's it. For the next one, we have these negatives as our exponents, so what we can do is we can flip. So we get b, well actually if we multiply the 2 times 2, we get b to the 4th over a squared. And then we can multiply this by b squared times a to the 3rd. And when we multiply, we just go straight across. So b to the 4th times b squared is b to the 6th. And a squared times a to the 3rd is a to the 5th. So b to the 6th over a to the 5th. Basic properties, make sure you know them. They come in handy for something like this. So the instructions say we have to use powers of the same base. So if I just put this in my calculator, it's technically wrong because I didn't follow the instructions. So what we can do is we can change the bases. So if we look, 3, 9, and 27, they're all powers of 3. So we have 3 to the 5th times 9 to the 4th. Well, 9 is really 3 squared. So we replace the 9 with 3 squared. And we have 27, which we can replace with 3 to the 3rd and raise that to the 4th. Now we can distribute our exponents. So we get 3 to the 5th times 3 to the 8th over 3 to the 12th. This is 3 to the 13th over 3 to the 12th, which reduces to 3 to the 1st, or just 3. Nice and easy. For the second one, we want to do the same thing again. Don't worry about these negative exponents. Let's just change these to bases. We'll change the bases. So again, 525 and 125 can all be written as powers of 3. Sorry, powers of 5. 125 is 5 to the 3rd. So we replace 125 with 5 to the 3rd. We replace the 25 with 5 squared. And we replace the 5 to the negative 8th with nothing. 5 to the negative 8th. It stays. So simplifying our exponents, we get 5 to the negative 9th times 5 squared over 5 to the negative 8th. This gives us 5 to the negative 7th over 5 to the negative 8th. Here we subtract. Well, negative 7 minus a negative 8 is really plus 8, so negative 7 plus 8 is 1. So we get 5 to the 1st. Two simple answers. So again, just make sure you're comfortable with rewriting. This is going to be important later on when we deal with logarithms. And same deal here. If we have these two equations, which if you try to solve this using logarithms, you're going to have a really difficult time. But if we change this to say, all right, 8 is really 2 to the 3rd, so we make that 2 to the 3rd to the x minus 1st power equals 2 to the x plus 1st. Distribute this in, we get 2 to the 3x minus 3 equals 2 to the x plus 1. Because the bases are the same, we can set the exponents as the same. So we get 3x minus 3 equals x plus 1. Running out of room here, so we'll just get 2x equals 4. So x equals x equals 2. Nice and simple. And for the next one, same deal. So we want to rewrite these. Now 27 and 1 over 9 aren't necessarily, I can't write 27 as a power of 9 directly. I mean, I could, but I'll have a fraction exponent. But I know some of you guys are not too comfortable with that, so I'll avoid it. But 27 and 9 are both powers of 3, so I'll rewrite them as powers of 3. So 27 is 3 to the 3rd, and I have 1 minus x as the exponent. 9, or 1/9, well, so 9 is 3 squared, so 1 over 9 is 3 to the negative 2nd power, to the 2 minus x. We can distribute our exponents, so we get 3 minus 3x. And over here we get negative 4 plus 2x. And again, the bases are the same, so I can set the exponents to be the same. So I get 3 minus 3x equals 2x minus 4. I can add these, so it looks like I'm going to get a little bit of a fraction, so I can add 3x to both sides to get 5x. Add the 4 to both sides, so I get 7. So I get x equals 7/5. And again, leaving that as a fraction is just fine. And so all this comes into play when we have these problems with logarithms. So here, if we have log base 3 of 27, remember, if we have log base 3 of 3, that reduces to 1. And 27 is really 3 to the 3rd. So this is a property that we have this exponent, which can become the coefficient. So we effectively have 3 times 1, which is 3. And for the next one, which is number 12, same deal. Natural log, the base is e. So we have natural log of e. That reduces to 1. We're left with the exponent, which is just 4. For the next one, same thing, except this one's already simplified. Log base 6 of 6 is going to be 1. 7 becomes the coefficient. So we get 7. Done. Log base 10 of 100. Well, There is no base here, so we assume it's base 10. It's called the common log, and 100 is 10 squared. So if we rewrite that, log of 10 is 1, because that's log base 10 of 10. So we're left with just the exponent again, which is 2. Here they start to get a little bit tricky. So we see that the log has a base of 4. So we want to rewrite this as a base of 4. But here we have a third root of 1/8. So we can actually take the third root of that. We can say that this is log base 4 of 1/2, which is 2 to the negative first power. And if we want to make this log base 4 of, should be a 4. If we want to make this log base 4 of 4, well, how do we rewrite 4 to be 2? Well, we change it to the 1/2 power. And now we have this negative 1. So log base 4 of 4, it reduces to 1. We have 1/2 times negative 1, so we get negative 1/2. That one's a little bit tricky, but it still follows the same rules. Here, we can rewrite this as natural log of e to the 1/5. Whenever we have a fifth root, it's a fraction exponent. And again, natural log of e reduces to 1, so we get the fraction 1/5. Oh, 17. Aren't you a fun one? So 17 is a little bit trickier in that we can't just drop this down. So actually what we want to do is we have this 2 here. We can drop this, or we can raise this to be the exponent, because right now this is a log. If I have 2 natural log of 7 just by itself, remember, just like I made the powers of the log here become the coefficients, I can make this coefficient become a power. So what this becomes is e to the natural log of 7 squared. E and natural log, they reduce to 1, so we're left with 7 squared, which is 49. And then the last two, we have our condensing and expanding properties. So here, if we're adding 2 logs of the same base, we can condense this by multiplication. This is the product property. So 25 times 4 is 100. So we get log of 100, which from number 14 we already established is going to be 2. And here we have same base. So we can subtract these 2 logs by dividing 250 by 2. 250 divided by 2 is 125. And if we want that 125 to be written with a base 5, well, 125 is really 5 to the third. Well, log base 5 of 5 reduces to 1, and we're left with 3. Okay, so a bunch of good little problems there. And the next page, not too bad. If we look here, right as a single log, these are your condensing properties. So when we condense and expand, there are 3 properties: product, quotient, and power. Make sure you know all of them. Here what I want to do is I can get rid of this power first. So I can do natural log of x plus natural log of y minus natural log of z squared. Then I can take them in order. So natural log of x plus natural log of y is natural log of xy, because I multiply, minus natural log of z squared. I'm subtracting, so I can write this as a quotient. So I get natural log of xy over z squared. And that is my answer. Here we can solve without using a calculator. This is going to be the same deal where we're using these properties. So here, if I have log base 2 of x squared plus 8. I can condense these two because they're both having the same base that I'm adding. X times 6 is going to be 6x. Base 2 means if the logs are the same, then what I'm taking the logs of must be the same. So that means that x squared plus 8 is equal to 6x. I can subtract, so I get x squared minus 6x plus 8 equals 0. I can factor this to be x minus 2, x minus 4 equals 0. So I get x equals 2, x equals 4. And yep, that should all work out. So, oops. So that is my answer. Okay, if I can figure this out. There we go. All right, so next up, same deal. We want to condense. So if that's 21, do 22 over here. So this is 22. We want to condense. When we're condensing here, first thing we want to do is we want to do this power property. So get rid of this coefficient. And we can do that by making this a log base 5 of x squared plus log base 5 of 3 equals log base 5 of 75. Condense the logs using the product property. So we do log base 5 of 3x squared equals log base 5 of 75. We can set these logs both equal to each other, so we get 3x squared equals 75. Divide by 3, x squared equals 25. So if we take the square root, we get x equals positive negative 5. But here, x is only going to equal the positive 5, because if I have x equals negative 5, I can't take the log of a negative value. So that would be an extraneous solution. And finally here, with this one, this is nice. We can just rewrite this. The base here is e for the natural log, natural base. So we can rewrite this to be e to the 0 power equals x plus 3. Well, e to the 0, anything to the 0 power is 1. So we get 1 equals x plus 3. Subtract the 3, we get x equals negative 2. And there we go. And finally, we want to solve the following with the calculator. So down here at the bottom of the page, we just have some warnings. Make sure that you're studying, doing all your appropriate material. Don't just study this packet and think, oh, that's good enough, because you need to study a lot more. Okay, so let's do, we'll do 24 down here. So 24, we have 5 to the 2x plus 3 equals 512. We want to rewrite this as a log. So we get log base 5 of 512 equals 2x plus 3. We can evaluate this using the change of base, which is log of 512 over log of 5 equals 2x plus 3. If we put that into a calculator, we get log of 512 divided by log of 5. My calculator shows that that's 3.876 equals 2x plus 3. And then, of course, we subtract 3 and divide by 2 to get that x is equal to 0.4. I'm struggling to write my 4s today. 0.438. That's not what I wanted. Okay. So that's 24. We can look at 25. Messing up my computers here. All right, so we get 3 log base 4 of x is equal to 18. Whenever you have a coefficient here, you could make it the power, but really the easiest thing is just to divide. So we get log base 4 of x is equal to 18 divided by 3, which is 6. And then we can rewrite this. So it's a log, So we write it as an exponential. 4 to the 6th equals x. And 4 to the 6th power is 4,096. So there we go. I don't know why that's doing that. And the last one, we'll go with, no, not red. A nice little teal color. Ooh, soft. All right, t to the 2e to the 3x minus 1 equals 12. Again, same thing as before, we can divide by 2, divide by the coefficient. So we get e to the 3x minus 1 equals 6. And now I can just rewrite it. This is a natural base, so it's going to be taking the natural log. So we get natural log of 6 is equal to 3x minus 1. Natural log of 6 right in the calculator is 1.792. That equals 3x minus 1. What we can do is we can add 1, and then we can divide by 3. So we get x is equal to 0.931. And those are the problems for Chapter 3 review. Again, you want to review everything from our quizzes, tests, homework. There are a lot of really difficult problems, but I mean, honestly, if you're just really comfortable with the basic properties, you can really manipulate these in any way you want. Happy studying!